Welcome to today's GATE coaching class. Myself Gowri, Assistant Professor, Department of Artificial Intelligence and Data Science at SC Engineering College. In today's sessions, we will discuss hierarchical clusterings, the linkage methods from the machine learning. So we will begin with the overview of machine learnings and clustering concepts, hierarchical clusterings and linkage methods, and we will solve some GATE questions. So first, machine learnings. Machine learning is a branch of artificial intelligence where machines learns patterns from the data instead of being explicitly programmed. So instead of writing rules manually, we give data to analyze the systems and it learns the patterns automatically. So once the data and the systems automatically run the programs, learn the patterns and make the predictions. So here the machine learning is classified as supervised learning, unsupervised learning and reinforcement learnings. So here supervised learnings. So supervised learning is one of the type of machine learnings where the model is where the data is labeled outputs. That means every input we have known the outputs data. So here each input has a corresponding correct outputs used for classifications and regressions problems. For example, SAM, email detections and house price predictions we are using comes under from supervised learnings. Here commonly algorithms are used for supervised learning means linear regressions, logistic regressions, support vector machines and decision trees. So unsupervised learning means where the model is trained using unlabeled data. Here unlabeled data means the data are not known about outputs. So there is no predefined outputs is used for clustering and associations problems. For example, customer segmentations, market basket analysis. Here we are using algorithms K means hierarchical clusterings and A prior. This models tries to find the hidden patterns or structured in the data. So reinforcement learnings. So reinforcement learning is the agent learns to make decisions by interacting with an environment, receiving rewards or penalties. Here this method is used for real-time experiments. So for example, for robot, AI, game player, self-driving car systems. Here this objective of the agent is maximize the cumulative rewards or the penalties over time. So here clustering. So clustering is an unsupervised learning to group the similar data points into clusters based on similarity or distance. So clustering comes from unsupervised learnings because data points in the same clusters are more similar to each other than to those in the other clusters. Why we are using cluster means to discover the hidden patterns, to perform the data segmentations, to reduce the data complexities. For example, say customer segmentations, documents groupings and image analysis. So while using clusterings, we have some common clustering algorithms are used, that is K-means clusterings, density-based spatial clustering of applications with noise and hierarchical clusterings. Today's sessions we will focus on hierarchical clusterings. So here K-means is a centroid-based algorithms. It's a work based for spherical clusters, whereas in density-based algorithms, it detects for noise effectively. Then hierarchical clusters is a build tree-like structures of clusters and is not required any predefined K, but it's a computationally expensive. Here hierarchical clustering we already discussed. Unsupervised learning techniques, it's a build a hierarchies, the tree structures of clusters. This output is represented using a dendrogram because we are plot step by step. That's why we are using hierarchical clusters. Here we have two types of clustering, agglomerative clusterings and divisive clusterings. So agglomerative clustering means it approaches bottom up techniques. Here we have following some algorithms. First we have to initialize each data point as a separate clusters. Then we have to compute the distance between all the clusters. We will find the minimum distance, and then we will merge the closest distance, and we will update the distance using linkage formulas. Still, until we have to repeat all the data points becomes one clusters. That's why we are using agglomerative clusterings. So divisive clustering means is a top-down approaches. It starts with all points grouped into one clusters. Whereas in agglomerative clusterings, we have to initialize all the data separately at each clusters. Whereas in divisive clusterings, start with all data points grouped into one clusters. It split the clusters by step. Once all the data will be clustered in one format, and then we will split the cluster step by steps. Then until each point becomes its own cluster. Still we have to split and merge find the distance between all the clusters. Then dendrograms. Dendrogram is a tree-like diagrams because we are using hierarchical clusterings. Here for x-axis we have to mention the points, data points, whereas in y-axis we have to find the distance between the points of the clusters. So it shows how clusters are formed, in what order they are merged or split, at what distance clusters are combined. So this is the output of the hierarchical clusterings. Once we have to cluster all the data, the output will be shown in the tree diagrams. Once we have to cluster the data, we have to use distance formulas. So suppose if you are 2D means we have to use these formulas, whereas 1D means we have to use x, y and xj's. We have to find the distance between the 2 points for either 2D or 3D of the data. For example, if given data is x is equal to 1, 2, 8, 9, here we have to split each data as a single clusters. So initial cluster is 1, 2, 8, 9. So we have 4 points means the initial cluster will be 4. So next steps we have to compute the distance matrix. So we have to use the 1D dimensions formulas. We have to find the distance marks. Suppose if you are using Suppose if you are using 1, 2, 8, 9 means this is our given data means the data should be. Now we have to find the distance. So here all 1, 1, 2, 2 will be 0. Then we have to find the distance. Suppose if 1, 2 means here 2 minus 1 is 1 because we have to separate highest minus lowest. So similarly for 8 minus 1, 7, then 8. Similarly for all the data we have to do. 2 minus 1 is 1. Then for 2, 8 is 6. 2, 9 is 7. So similarly 8, 1 is 7. 8, 2 is 6 and 8, 9 is 1. 9, 1 is 8. 2, 8 is 2, 9 is 7. Then 8, 9 is 1. 9, 9 will be 0. So this is how we have to compute the distance matrix. So after find the distance matrix, we have to merge the closest points. Here the closest point is 1. 1 is the smallest values. So we have to merge the 1 and 2. So here 1 and 2 we have to merge, and the remaining cluster will be in each single clusters. That is 1, 2 is the one clusters and 8, 9 is the separate clusters. Now clusters have multiple points. So here we have clusters have multiple points. So we need a formulas to calculate distance between the clusters. In this steps we have to use the linkage methods. From in this step onwards we have used for linkage methods. So we have to know what is the linkage methods and what are the types of linkage methods we are used for calculate the distance between the 2 points. So in hierarchical clustering, when 2 clusters are merged, we need rules to measure the distance between the clusters. So that's why the rule is called as linkage methods. Here main types of linkage method is single linkage method, complete linkage method, average linkage, centroid linkage and ward methods. This all the methods we have to find the distance between the 2 clusters. So we'll see single linkage means is the nearest neighbor methods. Nearest neighbor method means we have to find the minimum distance of the 2 clusters. So minimum distance between any pair of points, one from each cluster, is the single linkage. It is also known as the nearest neighbor methods. So for example, if you are taking two clusters like R and S, the single linkage distance is defined as L of R comma X minimum of D of Ij. Ij is nothing but is the distance between the data points of I and j. This is the distance between of the data points I and j we have to find. So it selects minimum distance between any pair of points from the two clusters. So single linkage is quietly opposite for complete linkage. In single linkage we used for minimum distance, whereas in complete linkage we have to find the maximum distance. So here complete linkage we have criterion used for agglomerative hierarchical clusterings. It is also called as the furthest neighbors methods. So here we have to find the maximum distance between any 2 points, one from each clusters. So here similarly for two cluster we have to take, and the single linkage and then complete linkage is defined as R of S maximum of Di comma j. Here is the largest distance of these two clusters. Once we have find which linkage is applicable for data, means we have to choose this or a single linkage. We have to find the spherical data and then we have to analyze the patterns. Then average linkage. Average linkage is nothing but the average of all pairwise distance between points in two clusters. So we have to find the two clusters. If you points two cluster means we have to find all the average of pairwise distance. So it usually results in clusters that are moderately compact by using average linkage. So this is because each clusters we have the average of all the data points. So here we are using the clusters of L of R comma S. We are using these formulas to calculate distance between the 2 points by using average linkage. So word linkage. So word linkage is nothing but the distance between two clusters by looking at total spread or variance increase when the clusters are combined. Here we are calculate the clusters total spread or variance, we have to increase the clusters. This method creates well separated clusters by making sure that data within each cluster is as similar as possible. It tries to minimize within the cluster sum of squares. Within the cluster sum of squares we have to mention WCSS. So this is a formulas by using for word linkage. For L of RS is we have to find the size of the clusters and the distance between the points of I and J. So last linkage is centroid linkage. Here centroid linkage is a hierarchical clusterings in which distance two cluster is calculated as the distance between their centroid means points. Centroid means points means center points of the data we have to pick the centroid linkage. Here the average of all the points in a clusters. So here this is a data is a centroid. So we have to find the distance of the two data points of centroids. So let's take an examples for linkage methods. Here given data point is one dimensional. Here A is equal to 1, B is equal to 2, C is equal to 5, D is equal to 8. Here we have to, given the data points, we have to calculate the distance between all the data sets. So for 1D we have to use these formulas. Then the distance matrix is already we discussed. If A means the value will be 0, B means the value will be 0. Similarly we have to find the distance of remaining clusters. So here the smallest values is 1. So here the smallest distance is B and A. So that's why the A and B has merged. So the new cluster is formed AB, remaining cluster is CD, because here A is 1 and B is 1. AB1, AB1. So the AB is new cluster and CD is the remaining clusters. So for we must calculate distance between cluster of AB and C, because here AB is already merged and the CD is a separate clusters. So here we have to cluster for all the remaining clusters, remaining points. So cluster A, B and C. So cluster A, B and D. The remaining cluster is C and D. So now we have to calculate A, B and C, and then A, B and D. Finally C and D we have to calculate the distance between 2 points. Here cluster A, B has 2 points. point means A is value 1, B is equal to 2, then C is equal to 5. So A minus C is 4 and B minus C is 3. So by using single linkage methods, we find the minimum distance of the 2 points. Here minimum of 4, 3. 4, 3 is nothing but is the AB values and C is 4, 3. The minimum value is 3. Similarly, ABD means the 7, 6. The minimum value is 6. So distance of C and D. So the minimum value is C. So now merge AB and C. So now we have formed on a new clusters A, B, C, D. So again we have to calculate for each points. So here A, B, C and D. Here A, B, C is 7, 6, 3. So the minimum value is 3. So final merge distance is 3. So here we have to merge order is 1, 3, 3. So here single linkages is to produce the chain link clusters. Next we will see some gate questions. In hierarchical agglomerative clusterings, which of the following linkage method is most susceptible to the chaining effects? Here chaining effects means this is the chaining line clusters. So here chaining method means the answer will be linkage method. The complete linkage, average linkage, single linkage and ward linkage. So here the answer will be single linkage because the minimum pairwise distance nearby creates long chains. That's why single linkage is the chaining effects. So next questions, let C1 and C2 be two sets of objects. Let D of x comma y, here C1, C2 is the clusters and D of x comma y is the data points. So be a measure of dissimilarities between two objectives x and y. Consider the following definition of dissimilarity between C1 and C2. Here the data will be given. DIS as C1 of C2 is a maximum of D of x. So maximum means we already know. Right. So DIS2 is minimum of D of x comma y. So minimum also we have to know. So here which of the following statement is or correct. So single linkage clustering uses DIS1 is right? No. So here single linkage clustering uses DIS2. Yes, here we are using minimum data set, minimum distance matrix. So here single linkage clustering uses of DIS2. So next complete linkage clustering uses DIS2 means no. So next complete linkage clustering uses DIS1 means yes, because here we are using maximum distance between the clusters. So the answer will be B and D because the single linkage uses minimum dissimilarities whereas complete linkage uses maximum dissimilarities of DIS2. So next questions, in hierarchical agglomerative clusterings, which one of the following linkage criteria is equivalent to of merging clusters such that the increase in within cluster sum of squares? Already we discussed. Within cluster sum of squares means we know that is ward linkage because already we discussed. Here we are using, it tries to minimize within the cluster sum of squares. So here the direct answer, the direct questions is ward linkage. So next questions, consider same 1D data points, same questions, A is equal to 1, B is equal to 3, C is equal to 10, D is equal to 12. Here see, using single linkage, what will be the first two merges? So first two merges means we have to know the minimum distance of the data points. Here compute distance means 1, 3, then 10 to 12, then 3 to 10. So that means A minus B, C minus D, then B minus 10. Here 2 to 7. Here 2 is the minimum values. Then A, B we have to join and C, D will both the distances 2. So answer is first two mergers is A, B and C, D. So this is the gate tricks for remembering. Here method means single method, the distance used is minimum. So effect is chaining effects. For gate keyword, nearest neighbor we are using means if it is questions ask nearest neighbor or single linkage. Similarly complete means furthest neighbor is also known as complete linkage. So the distance used is maximum. So here effect is compact. Whereas average means we have to calculate the mean of the pairwise distance. Here effect is balanced and the keyword is group average. Then what linkage is? Variance, it's a compact or a spherical. Here we are using WCSS. So centroid means mean point of the distance. The effect is inversions possible. Gate keyword is non-monotonics. So thank you. We'll continue on next class.